December 22nd, 2025. As 32 million Californians prepared for the holidays, forecasters did something they almost never do. They issued the highest flood alert possible. It was not just rain. It was an atmospheric river from Hawaii, ready to unleash a year's worth of water in days. When official warnings are not enough, what happens when the ocean itself invades Los Angeles? The answer begins here. National Weather Service forecasters gathered in front of their monitors on December 22nd, 2025, watching a mass of tropical moisture stretch across the Pacific. This was no ordinary winter system. Satellite data traced a plume of water vapor from Hawaii all the way to the California coast, a classic Pineapple Express loaded with months' worth of rain. By midday, the Weather Prediction Center issued a Level 4 high-risk excessive rainfall outlook. That is the highest alert in their system, reserved for the rarest and most dangerous storms. In any given year, less than 4% of days ever reach this threshold, yet these days account for the vast majority of flood damage and deaths nationwide. The decision was not made lightly. Forecast models showed integrated vapor transport, essentially the amount of water in the air, reaching levels seen only in the most extreme atmospheric river events. Rainfall rates were projected to overwhelm city drainage and mountain streams alike. The ground across Southern California was already saturated from earlier storms, leaving nowhere for more water to go. By the time the Level 4 warning went public, flood watches blanketed the maps from San Diego to Santa Barbara. 32 million people, nearly the entire population of California, were put on alert. Emergency managers scrambled to prepare. For days, meteorologists had tracked the system's every move, debating when to escalate their warnings. Now, with the storm's arrival certain and the risk of catastrophic flooding clear, there was no room for hesitation. The Pineapple Express was set to make landfall. The region braced for impact, knowing that on days like this, the odds of disaster shoot sky high. The flood risk was not just theoretical. It was written into the very forecasts trusted to protect lives. As the first drops began to fall, the city's fate would hinge on the accuracy of these warnings and the willingness of millions to heed them. Christmas Eve arrived under a sky boiling with dark tropical clouds. By dawn, rain hammered Los Angeles with a force rarely seen in a generation. The city's official downtown gauge began ticking upward, hour by hour, as bands of moisture swept in from the Pacific. In a typical December, Los Angeles expects barely 2 or 3 inches of rain for the entire month. On this day alone, the city saw rainfall totals that dwarfed the seasonal average, with meteorologists noting the highest Christmas rainfall in more than half a century. Streets that usually shimmer with holiday lights became rivers of runoff, water swirling around curbs and pooling at every low point. Across the basin, rain gauges told the same story. In just 48 hours, coastal and valley neighborhoods collected 4 to 8 inches, more than a month's worth of rain in 2 days. The foothills and canyons, squeezed by the storm's relentless push, recorded even higher numbers. In the San Gabriel Mountains, gauges near Wrightwood measured totals approaching 10 inches. For some communities, it was as if half a year's rain had fallen before the holiday was over. The air itself felt saturated, heavy with the scent of wet earth and the distant tang of smoke from hillsides still scarred by last winter's fires. The ground, already soaked from earlier storms, offered no refuge. Water streamed across driveways and parking lots, unable to soak into soil that had reached its limit. In neighborhoods built at the foot of steep slopes, the risk grew with every passing hour. Each new burst of rainfall meant more pressure on the hills above, where burned and barren land could no longer absorb the deluge. Emergency alerts pinged across phones, warning of flash floods and debris flows, but the rain did not let up. By nightfall, the city's infrastructure strained under the weight of so much water. Storm drains gurgled and overflowed. The Los Angeles River, often a lazy trickle in December, surged with muddy runoff. In the mountains, the storm's true danger was only beginning to reveal itself. As Christmas lights flickered in windows, the rain continued, unrelenting, indifferent, and poised to bring a new disaster down from the hills. Wrightwood sits high in the San Gabriel Mountains, a place where winter usually means quiet streets and snow-dusted rooftops. On Christmas Eve, that changed in a matter of hours. Rain hammered the hillsides, pouring down at rates the town had never seen. Runoff raced through canyons stripped bare by last January's wildfires, carrying with it a tide of mud, rocks, and broken branches. Water surged through the town's main streets, churning brown and fast, swallowing everything in its path. By midday, cars parked along Elm and Apple Street disappeared beneath a rising sea of muck. In some blocks, only the tops of street signs and the occasional mailbox hinted at what lay beneath. Residents who had woken up to the sound of rain now found themselves trapped behind doors jammed with debris. In one neighborhood, the mud piled so high against homes that front porches vanished, and ground floors turned into muddy tombs. Several houses reported 5 feet of mud and water inside, enough to reach halfway up the windows. Across town, garages filled with holiday decorations and family keepsakes became unrecognizable. Sheds and fences broke loose, tumbling downstream. Pickup trucks, once parked in driveways, sat buried to their windows. For some, escape routes closed off within minutes. The only way out was up, a scramble to second floors or rooftops as the mud kept rising. Phone lines buzzed with calls for help, but emergency crews struggled to reach the heart of the disaster. Roads leading into Wrightwood were blocked by landslides and boulders, turning the town into an island surrounded by a moving wall of earth. Every corner of Wrightwood bore the scars of the storm. The scale of destruction was measured not just in inches of rain, but in the height of the mud that now defined the landscape. For many, it was impossible to tell where the mountain ended and the town began. In the chaos, the stakes became clear. Survival depended on how fast help could arrive, and whether it could get through at all. Wildfire transforms a hillside in ways that cannot be undone by a single season of rain. When flames sweep through, they do not just burn away trees and shrubs, they change the very chemistry of the soil. Heat from the fire vaporizes plant oils, and those oils settle deeper into the ground, forming a thin, invisible layer that repels water. Scientists call this hydrophobic soil. On a normal hillside, rain soaks in, slowed by roots and leaf litter. After a fire, water beads up and races downslope as if poured onto glass. Even moderate rainfall can trigger rapid runoff. With an atmospheric river overhead, the effect multiplies and the runoff becomes immediate and violent. The 2018 Montecito disaster remains a stark example. There, half an inch of rain in 5 minutes unleashed a torrent of mud and boulders, moving with enough force to destroy homes and claim lives. In Southern California, the hills above Pacific Palisades, Malibu, and Altadena were left stripped and raw by the January 2025 fires. The USGS has documented that rainfall rates as low as 0.3 to 0.5 inches per hour on these burn scars can be enough to spark debris flows. These flows are not just muddy water. They are thick slurries of ash, rocks, and shattered trees, capable of moving at highway speeds. When the Christmas storm arrived, the rain did not seep into the ground. It gathered on the surface, accelerating downhill and scouring everything in its path. Culverts and debris basins designed for ordinary storms clogged quickly with branches and sediment. When a single channel failed, the slurry jumped banks and poured into neighborhoods below. In those moments, the hills that once burned became the source of a new disaster, setting off a chain reaction that would test every emergency system in Southern California. Misty Chung's phone buzzed with a video from her neighbor. The screen filled with churning brown water pouring through her backyard, swallowing the patio furniture and creeping toward the door. She was miles away, stranded by closed highways, powerless to do anything but watch as her home filled with water. By the time she returned on Christmas Day, the mud line on the walls stood waist high. She called it literally the nightmare before Christmas. Caitlin Johnson did not see the danger coming. Early in the evening, rain pooled quietly in the street. She glanced outside, thinking it was nothing unusual. Within an hour, a torrent ripped through her fence and surged into the living room. The water tripled in size, climbing the walls, forcing her family upstairs as the ground floor disappeared beneath swirling mud. The sound of debris battering the windows drowned out any holiday cheer. Dylan Brown, his wife, and their 14-month-old daughter were stranded in a rented cabin up in the mountains. Food was running low, and they had just enough diapers for another day. With every road out blocked by rocks and mud, help seemed impossibly far away. Dylan's wife posted a plea for help on Facebook. Within an hour, headlights cut through the storm. Neighbors arrived on foot and in trucks, carrying bread, vegetables, milk, diapers, and wipes. In the absence of rescue crews, the community became its own lifeline, passing supplies hand to hand through the rain. For families like these, survival depended on the kindness of strangers and the speed of a message sent out into the storm. Helicopter rotors cut through the storm above Wrightwood, their searchlights sweeping over rooftops half swallowed by mud. On the ground, firefighters faced a wall of debris, roads vanished, driveways erased, and streets impassable even to the biggest rescue trucks. Cody Burgess stood in his yard, watching as a Los Angeles County fire helicopter hovered over his neighbor's home. Inside, 3 people waited on the roof, water pouring from broken windows, mud swirling around the eaves. There was no way for ground crews to reach them. Every route was blocked by landslides and churning floodwater. The only choice was to lower a rescue harness from above, one by one lifting them out of danger. This scene played out again and again across the county. Fire department logs would later count more than 100 people rescued by air, each one a story of desperate calls, impossible access, and split-second decisions. The scale of the operation pushed every resource to its limit. Radios crackled with urgent requests for more helicopters, more crews, more time. Neighbors who could not be reached by official teams turned to each other, sharing supplies and information, forming human chains where vehicles failed. The storm had turned familiar streets into islands, and for many the only way out was through the air. Yet even as the rescues continued, the strain on the region's emergency systems grew more visible with every hour of rain. Interstate 5, the backbone of California's road network, was transformed into a river. Near Burbank Airport, lanes that usually carry thousands of cars an hour vanished beneath swirling brown water. Engines stalled in the rising flood, forcing drivers to abandon their vehicles in the middle of their commute. With Interstate 5 closed in both directions, traffic spilled onto surface streets, but those too were quickly overwhelmed. On Christmas week, one of the busiest travel periods of the year, highways across Southern California locked into gridlock. 14.5 million Californians had planned to travel, but the state's arteries had failed. Emergency alerts warned, "Do not attempt to drive, roads are impassable." The storm's power did not stop at the freeways. Wind gusts topping 60 miles per hour snapped power lines and uprooted trees, plunging neighborhoods into darkness. By nightfall, more than 120,000 customers were without electricity. Utility crews struggled to reach damaged substations as floodwaters blocked access roads. Traffic signals flickered out, compounding the chaos on streets already jammed with stranded vehicles. For many, the only light came from headlights trapped in the gridlock and the flash of emergency vehicles weaving through the dark. The city's infrastructure, engineered for a different era, buckled under the relentless assault, with no relief in sight as the next wave of rain loomed offshore. The rain did not stop. Even as the first atmospheric river moved east, a second surge of subtropical moisture barreled toward Southern California on Christmas Day. Another 1 to 3 inches of rain fell onto ground that could not absorb a single drop more. Flood warnings stretched across 5 counties. Governor Gavin Newsom declared a state of emergency for Los Angeles, Orange, Riverside, San Bernardino, San Diego, and Shasta counties. The California National Guard was placed on standby, ready to deploy if conditions worsened. Emergency resources poured into the region, but the damage was already mounting. By the end of Christmas week, 4 people had lost their lives. In San Diego, a 64-year-old man was killed when a tree, its roots loosened by saturated soil, crashed through his home. Sacramento County lost a sheriff's deputy, James Caravallo, in a crash as he drove to work through the storm. In Lancaster, a car was found half submerged in mud, the driver unable to escape. Another victim was pulled from floodwaters in Los Angeles County. 4 families spent the holidays grieving. Their loss is a stark reminder of the storm's reach. For millions, the disaster was measured not just in flooded homes or lost power, but in the names and faces of those who did not survive. Ocean temperatures off California in December 2025 ran far above normal, setting the stage for a storm that was anything but ordinary. Warm water in the Pacific acts like fuel, loading the atmosphere with extra moisture. When a Pineapple Express taps into that heat, the result is an atmospheric river that carries more water than storms of the past. Climate scientist Daniel Swain put it plainly. December 2025 is likely to end up as the warmest on record. That warmth did not just break records, it changed the storm's behavior. Research shows that as the planet heats up, the atmosphere can hold more water vapor, making heavy rain events more intense. Atmospheric rivers like this one are now arriving with greater frequency and strength. The Christmas floods were not a fluke. They were an example of how a warming climate is amplifying California's wet extremes. What once seemed rare is quickly becoming the new normal for the West Coast. Today, California faces a future where record heat feeds record storms and burn scars turn rainfall into catastrophe. Atmospheric rivers now deliver more water, more often, to cities unprepared for the extremes. The boundaries between fire and flood are gone. As climate accelerates, resilience is not optional. It is survival. The next storm is not a question of if, but when. Please share your thoughts and experiences in the comments below.